Hello, and welcome to InflectraCon 2020. This track is about Inflectra in real life, and the particular topic we wanted to talk about today was Spira for non-software applications. We have one major example, COVID-19 mask testing, and another smaller example we'll get to if time allows, which revolves around railways. My name is Neil Price-Jones. I'm the president of MVP Software Solutions in Canada, and we support and implement some of the Inflectra products in Canada for various clients. Oddly enough, despite the fact that we are in software, most of the clients recently have not. We've had a railway client who is more interested in controlling his railway projects, and we have someone who's worried about testing masks for COVID-19, which, as you can well imagine, is not really software related. However, as a starting point, we thought we'd go through the 5 standard stages of a software testing project and see how they related to what we have to do now, because we do start with something that we want to map. So normal conditions in software, we normally start with requirements. Whether those are business requirements, technical requirements, upgrade requirements, it doesn't matter. With some luck, someone has put some thought into what they want or where they want to end up. Sometimes these are very formally recorded, signed off, and only changed under a change request process with formal sign-off for that. Other times they exist in somebody's head, or they're scribbled on the back of an envelope, as the case may be. But having got requirements, we then tend to design some sort of system. And I've seen anything, I'm sure you have, from very complex designs with many, many different layers, including applications and communications and IP addresses and ports that are open and closed and machine overlays, etc., all the way up to a nice little sketch somewhere on a board or on the back of an envelope, if you have nothing else, that designs the system, and pretty well everything in between. Once we have some sort of design, whether it's written down or not, generally we move to some sort of development process or maybe a coding process. That may be purchase software, maybe COTS, commercial off-the-shelf software, purchase and configure, or we may be building from scratch. I've certainly seen all 3 or 4 versions, and I'm sure you have as well, plus possibly some others. Now, for those of you who have been in test, you would probably guess that we would want to do a lot of testing already. The shift left motion was part of that. Verification of the requirements, verification that the design reflects the requirements and that the code reflects the design, etc., before we get to a formal active test, which comes in the next step. But even with the greatest use of verification techniques, we still end up with a validation test. Sometimes those are non-functional deliverables. Sometimes we want to ensure the function does work in the environment in which we're going to place it. And we certainly have some last-minute tests that come up where we want to look sometimes at procedures or operational aspects that need to be in line for the thing to go live. Assuming the test all goes correctly, we end up with a deployment phase whereby we actually deploy the code into production and start looking around for the next project. Some people throw on a 4th phase to that, or a 6th phase called maintenance. I'm including that in deployment on the grounds that you're doing that at the same time and continuing on. So that's standard. I'm sure most of you have seen it. Most of you have probably tested in it at one time or another. Our conditions are a little bit different. We have requirements. That's not an issue. We definitely have requirements. They are written. They are well written. They are fully documented. They have been signed off electronically. They're in a fixed document, and they're not changing without a fair bit of effort. So that's not an issue. We certainly have requirements in our non-software project. However, we have no system design, as you can see from the square I've blocked out here. There is no system design in this case because we have no system as such. We're not actually testing a system, we're testing a mask. And that is not part of a system in the way that we understand it. So similarly, as you can probably well imagine, we also have no code because there is no code, at least not now, in any of the masks I've dealt with, and I'm sure not in these either. So we have no code, we have no system design. We still have our requirements, well written as I said, and there. And then we definitely have a stack of very, very critical testing to do. So really we're moving from requirements directly to test, and that is not unusual. It can be done in software projects. It's just that we don't have code to deal with, and that has some ramifications for later on. Of course, eventually if the tests all pass and people are happy, we do expect to deploy these masks into a production environment and make use of them. Incidentally, they are in the process of redesigning as we speak because certain of the tests that have been done so far have not worked out. So, what are our conditions for this test when it's not software? Well, as I said, we do have requirements, and the question is, what sort of requirements and how are they different from what we're used to in terms of software? Well, there are three major divisions that I sort of came across. One is physical requirements, one is recording requirements, and one is emergency requirements. These are disputable. You probably could think of others, but they were a good division as a starting point when we needed to decide how we were going to divide up the tests and record them. So the physical requirements: put the mask on, take the mask off. Seems simple enough, but the fact is that we need to make sure this works. It doesn't fly off our heads, which I've known them to do. It's comfortable for extensive wear, and it can be taken off without problem in the event of an issue. And you'll see some of the issues in a couple of slides. Obviously, number two, wear a mask while carrying out duties. It's pretty much useless if we put it on and take it off, but can't actually use it when we're doing what we need to do in this particular organization. And then make sure the mask does not interfere with normal operations. Well, there is absolutely nothing normal about the operations that they're dealing with. So normal is actually what we would generally constitute as abnormal. And then, if we get it done correctly once, we need to repeat under varying scenarios. So this is a generalized sort of test where we need to repeat it under various environments, which effectively is what we are having with our various scenarios. Then I talked about the fact that we had recording requirements. Well, unlike the normal project where we would repeat the bug, and we'll talk about this, we gather up all the information about it, we need to record results where there is no access to a PC, to a laptop, to a tablet, to a phone, etc., etc. Nothing is there. They don't have room for these where they're using it. So we're back to good old paper. And that is one of the requirements for recording, is that the results can be recorded on paper and subsequently placed into a system for decision-making processes. Not a big change from some of what we used to do, but definitely a change from current practice where everything is recorded without the use of paper in general. It's very rare now for us to print paper and look at it. It certainly needs to be accurate for all the conditions under which we're operating, so we can't have our reports coming in on paper and have them be inaccurate, because that will obviously invalidate the test. And sometimes it's going to be extremely difficult for them to record the results of the test at that time. It's going to simply be very hard for them to be doing their work, testing the mask and recording the results. So we do have to worry about accurate recall later. And then finally, there's what I would call the emergency requirements. So during the test or during actual use, things may occur that simply weren't anticipated under any conditions. Everything is not necessarily going to operate the same way every time. Yes, we can anticipate a fair chunk of it. Yes, we could do what-if scenarios. We could do guessing. Not something that we can miss, but definitely there could be other things that could come up where we have to think, okay, what is the quickest way of handling this while still worrying about properly testing the mask, or if it's in production, properly using it. So I'm referring to those as emergency requirements. You could classify them differently, but that is one way of dealing with it. So the question is, where does Spira come in? Well, so far so good. Not a big issue. Software has requirements, so does this system. Same type of thing. So I can record all these requirements into the tool without issue. The weird thing is, these people have never thought about recording anything into any tool of this type. They've simply thought about putting it into a Word document. Photocopier gets a bit of a workout. Everybody gets a sheet of paper, and then we sort of collate it by hand after. And 6 or 7 weeks after they actually run the test, they kind of get to the point of saying, gee, it works, or it doesn't work. And we don't have that type of time anymore. So that's enough about requirements. As I said, we don't really have a system design. We don't really have code. Well, we almost definitely don't have code in a mask. So our conditions for the test is how we have to test it to make sure that it is correct. So what sort of tests are we doing? And again, I made 3 categorizations. Again, these could be disputed, but under conditions of non-stress, under conditions of stress, and then emergency type tests where we're reacting to something that might not be standard, but definitely has to be considered. So what are we looking at? Well, non-stress tests. Test the mask when not under stress. So we have lots of time and we're not doing anything else. We're actually not doing our standard work. Putting it on, taking it off, and taking the time to adjust it to fit, etc. And I've been through this, with the old mask, not under these conditions. And certainly it takes a few minutes when you're new to it to put it on and adjust it and get it right so it doesn't burst off, and then take it off later when you get out of the store or wherever you happen to have been. Certainly those are the conditions under which we're living right now, and these are the conditions they need to test. So those are the easy ones. That has time. We still need to record it. We still need to hold it to say, yes, it could be done. But in general, these will probably pass for most of the masks. However, testing the mask when under stress, and that is really the import of the test, is a little bit different. So maybe rushing to put it on when people are wearing a helmet. And I've tried to put it on with a bike helmet. Doesn't work. Wearing goggles. Tried it with glasses. They steam up. Haven't tried it with wearing a throat microphone, although I could try it right now. But these are all conditions that these people work under on an ongoing basis. So they need a mask that suits when they're wearing a helmet, somewhere to hook it to, when they're wearing goggles and need to be able to see, not just under conditions of normal wear, but under conditions of stress as well, and potentially wearing a throat microphone. In addition to that, while they're operating critical equipment, again, they don't have time to be playing with the mask or adjusting it when they're operating under work conditions. They are operating under fairly extreme conditions, and they're operating critical equipment, which requires their full attention. The mask has got to be unobtrusive, you might say at that point. Communicating with controllers, communicating with colleagues, and then putting this all together all at once. In addition, of course, as I said earlier, we might have the emergency tests, a sudden need to either put the mask on or take it off, also while under stress conditions. For whatever reason, clearly you can't sacrifice some things to having a mask on. You need to get the mask off and get to work under the conditions of being without it. So this has to be also a possible positive result from the test. So if this was software, what would I do? Well, anytime I decided something had failed, I'd repeat the bug. I'd capture the actual results. And then I would capture the data, the machine status, how I got there, what I expected, what I saw, any other information I had, any judgment calls, etc., etc. I'd record all of that into the bug, press the bug button, and off it would go into the system. Well, we don't have that here. Here we have potentially no repetition of the bug. If they find out something during the test, they are not going back to the same conditions to repeat it. They're simply going to say, it didn't work at this point. That is my opinion or my result, and end of story. We don't have any repetition to work that out. We won't be able to capture the actual results, unless we put a camera somewhere, of what happened. Didn't it work? Couldn't breathe, could not see, whatever. Whatever the problem is, it's going to be reported. It actually is not going to be able to be recorded. And there is a difference. There won't be much in the way of data. There may be no lead up or nothing available. We've got that type of condition where they say at this point it failed and we couldn't go forward. In addition, of course, as I mentioned earlier, the results will be captured on paper reports at the time of the test or shortly thereafter. So what are we gaining here? Well, once the test is over, people are back at site, wherever that happens to be, then we're going to take the results of that test and feed it into Spira. So what happened in the past was they collated them, they manually recorded pass, fails, they looked at each one, why was it considered a pass, why was it considered a fail, they made a decision, they collated or counted the numbers of passes or fails, looked back if it was, very much in one direction or the other, and tried to decide where to go. Well, the whole concept, of course, of being able to record them is that the results will be categorized as a pass or a fail after the event, but immediately upon recording. So instead of waiting 5 or 6 weeks and kind of looking at it and saying, well, did this pass or fail? It's going to be dropped into Spira. Certain of the fields will be set as drop downs. The others will be set to say, well, based on what we saw, this is a pass or this is a fail. The person who did the test will be able to sign off on it and say, yes, I agree that I was successful or that it failed and we can't go forward immediately. There will be no waiting. As soon as those results are into Spira, the decision can be made. So they'll be captured on the paper reports, probably retained on the paper reports, but keyed into Spira immediately, and the results will be available immediately. Within almost instantly after it's been put in, you will have the results of how many passed, how many failed, and be able to make the decision. And this is the key categorization that they want out of Spira, is the ability to make the decision instantly. What they don't have now is that ability. They have to wait and wait. Now they'll have trends. Now they'll have decision points. They can decide immediately. So the results will be categorized and the decision will be available. So as I said, results captured on paper reports will be collated. Even if the test is partially over, we can issue a report of what has occurred to that stage and sit there and say, this is going well so far, we can continue on, or this is failing every place we want, this is not acceptable, abort the rest of the tests, and we need to redesign the mask to suit ourselves. So we have an instant decision as opposed to a delayed decision. So why bother with Spira? Well, it's currently taking far too long to generate the completion report. Too much collating of data, too much waiting, too much time. Now we will have the results immediately after entry. Tests will be classified as pass or fail immediately, and we'll be able to make that decision effectively immediately. So we'll cut a lot off the cycle time that's currently running. As I said, reports can be run immediately, and redesign of the mask based on problems can start. May not be done immediately, but it certainly can start on why is this going wrong. All the information will be available in there, and we can sit there and say, this mask causes problems X, Y, and Z. We need to fix those on the next version of the mask. And effectively, our test cycles are versions of the mask. That's what they're going on. I mean, when they get a new mask, it'll be a new set of tests. Again, the same type. We gather up the previous tests minus their actual results, and we start rerunning them. Right now, that means a whole bunch of paper, a whole new setting. From Spira, it just means reset to 0, gather up the tests. Any tests that needed to have been changed will have been changed. Everything else will be ready to go, and we can move forward based on our previous analysis with a new mask and see that it's fixed and that we can get a new answer. So again, why bother with Spira? Save a lot of time and money in manual work, the manual entry, with of course the potential chance for error. There is a possibility that some of the manual work, some of the collation will miscount and the results will not be correct. There is still that chance, obviously, with the entry, but if we can enter it within a certain time after the test is actually finished physically, and then turn around to the person who did it and say, is this what you reported? And they can sign off on it and potentially compare it, then we've got a perfect result immediately. We don't have to worry about going back 6 weeks later and saying, do you remember what the results were? It'll be immediate, and we'll have more accurate results sooner. So results are all centralized and retained for future use. Not only do we have it for now, we will have it for future. If somebody comes back and says, well, how did you ever pass this particular design of this mask? Why did you agree to go forward with it? It's not working for me. We'll be able to pull up the results and say, as of the time we tested it, it was working. Maybe there's a new condition. Maybe there's a different issue. Maybe there's been a change in the way it's been built. Who knows? But the fact is that we will have all of those results at our fingertips in Spira, and we can look at them immediately and say, well, that was the decision we made based upon the information we had at the time. Right now, they have to go through all the manual reports and say, well, it was reported as good or bad or whatever, depending on what was there. That's the reason we're pushing to put Spira in there. They feel that they can make use of it to vastly speed up their execution cycles and vastly speed up and improve the quality of their information so that they can make decisions that much sooner. And that is the real reason behind it, is instantaneous decisions. Now, I mentioned at the beginning that the other one was a railway application. These people build, mainly it looks like urban railways for a living or for a job, you might say. And there is a lot of contract information that they need to retain over time, and a lot of tests they need to run to make sure that the physical things that go into the building of this particular urban railway are in place. And some of them are very fascinating to someone who's just been in software for most of his life, talking about how drainage needs to go away from the rail. Makes perfect sense, but it wasn't something I realized had to be in an agreement. Or else any obviously utility lines that they run into need to be repositioned before they can continue to work. If they're working, for instance, on a subterranean railway, for example, a subway or something. So a lot of these, they need to be done, they need to be tracked, they need to be tested, they need to be sure that they are correct. And this is the sort of information, again, that they want to track in Spira. They have requirements, again, very validated and very precise requirements. They don't have a system design. They don't have code. Yes, there is code for subways, but it's not the piece of building it, it's the piece of running it generally. And they have a need for tests, and they have a need to be able to go forward. So they have a need to obviously to deploy the solution that they have determined under the conditions that they tested it and make sure it is correct. So two very interesting applications of Spira to non-test methodologies. And we are interested in seeing these because we've always thought of most of the test tools as being software related and definitely not related to building subways or things like that. And we feel this is an interesting application that will expand the use. I'd just like to set it open for any questions you have and look forward to any comments you might have about what was said or any other examples you might have that would expand the horizon of what we've done. Thank you very much for your attention, and I'm looking forward to speaking with you at a convenient time. Thank you.